Welcome to the session on constant acceleration, vertical motion under gravity. The objectives for this session are to use the constant acceleration formulae to solve problems involving vertical motion under gravity. Objects accelerate to Earth due to the force of gravity. If air resistance is ignored, this acceleration is constant and is not dependent upon the mass of the object. So, in a vacuum, a feather and an orange accelerate downwards at the same rate. On Earth, acceleration due to gravity is approximately g equals 9.8 meters per second squared. Acceleration can vary on Earth by small amounts due to differences in the radius of the Earth and the height above sea level. The positive direction can be up or down. If we consider the positive direction to be down, then g is positive. So g equals 9.8 meters per second squared. And if the positive direction is considered upwards, then g is negative. So g is minus 9.8 meters per second squared. In mechanics questions, g is equal to 9.8 meters per second squared. If a different value of g is specified, such as g equals 9.81 meters per second squared or g equals 10 meters per second squared, do ensure that the degree of accuracy is consistent in your answer. Let's now take a look at some notation. The total time an object is in motion from the time it is projected to the time of return is called the time of flight. So in this diagram, a ball is tossed upwards, reaches a maximum height, and then falls downwards again. T is the total time it takes to complete this journey. The initial speed of projection is u. Now recall the standard notation for an object moving in a straight line with constant acceleration. Remember that s equals the displacement, u the initial velocity, v the final velocity, a the acceleration, and t the time taken. We now also have g, the force of gravity, which is 9.8 meters per second squared, but this takes the place of acceleration. Recall also the formulae that we introduced in the last two sessions. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So here's what's happening in pictures. A ball falls off a shelf and then bounces up and down. So let's take a look at example 1a first. We are required to find the time the ball takes to hit the floor and the velocity on impact. We're going to take the downwards direction as the positive direction. So when the ball falls off the shelf, we have the initial velocity as 0 meters per second. Gravity or acceleration is equal to 9.8 meters per second squared. The distance it travels is 1.5 meters, so s equals 1.5 meters. We are required to find the time the ball takes to hit the floor, so t. We're also required to find the velocity, But let's take a look at time first. In other words, we have S, U and A, and we are required to find t. So we are going to use this equation, S equals ut plus a half at squared, because it includes all of these values or these letters. So let's solve this. We're going to substitute in all the values into this equation. We have S equals 1.5 here, U equals 0 here, A equals 9.8 here, and of course t remains as it is. Tidying up and rearranging this equation gives us that t squared equals 3 over 9.8. So t is equal to 0.3 seconds. We're going to ignore the negative value of t, as time, of course, is not negative. Now let's find v. Again, we're going to take the downwards direction as the positive direction. So we have S, U and A, and we are required to find v. And therefore we are going to use this equation, v squared equals u squared plus 2as. And plugging in the values into this equation, we have v, because we're looking for v, we don't know what it is yet. U equals 0, A equals 9.8, and S equals 1.5. And calculating gives us v squared equals 29.4. Therefore, v equals 5.4 meters per second. We're going to ignore the negative value of v, as travel is in the positive direction. Now let's attempt part B. We are required to find the maximum height above the floor after the first rebound. Notice we've highlighted something else in this example. We've highlighted the fact that the ball rebounds with 3/5 of the speed with which it strikes the floor. We've noted from the previous part that the velocity is equal to 5.4 meters per second on impact on the first bounce. Therefore, the return velocity is 3/5 of this, therefore 3/5 of 5.4 meters per second. And this equals 3.2 meters per second. So let's solve this. We have on the next part of our journey that the initial velocity is 3.2 meters per second. We have that g, or acceleration, is equal to 9.8 meters per second squared. And we have that the final velocity, v, is equal to 0 meters per second. And we would like to find the maximum height, s. So we have u, v and a, and are required to find s. Therefore, the equation we are going to use is v squared equals u squared plus 2as. So let's plug in the values. Here we have v equals 0. Here we have u equals 3.2. Acceleration or g equals minus 9.8, because now we're treating the upwards direction as the positive direction. And finally s, the distance, which we are trying to find. Therefore, rearranging this, gives us that s is equal to 0.5 meters. This brings us to the end of this session. If you have understood its contents, you should be able to use the constant acceleration formulae to solve problems involving vertical motion under gravity. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.